The Robotics Industries Association has prepared the technical report RIA TR R15.606-2016 to enhance the safety of personnel associated with collaborative robot systems. Although it is a direct adoption of ISO TS 15066, it is a technical report and has not matured into a standard yet. The intent is to gather inputs from the standard users, for example, robotic integrators, which feed into the technical committee. The technical report makes normative references to various standards. ISO 10218-1, 2011, Part 1 talks about safety requirements for robots. Section 2 talks about robot systems and integration. ISO 1200 specifies the fundamental principles to achieve safety in the design of machinery. Risk assessment and reduction tools are included to continually mitigate risks. ISO 13850 and ISO 13855 talk about emergency stop functions and positioning of safeguards with respect to the approach speed of a human body. IEC 6204-1 includes general requirements for electrical equipment used in machinery. Collaborative robots and their applications is a continually evolving field. This lesson will build an appreciation and understanding of different parts of the technical report. This knowledge will be beneficial in proactively thinking about safety essentials for collaborative robots. Let's dig in. The technical report takes a process approach to establishing safety essentials for collaborative robots and systems. There are two central concepts in the technical report, which are collaborative robot systems design, Clause Section 4, and requirements for applications, Clause Section 5. Clause Section 4 talks about inherent safety design features, which incorporate requirements for design factors, hazard identification, and risk assessment. It also addresses an approach to mitigate and reduce the effects of a hazard. Clause Section 5 prescribes requirements for collaborative robot system applications. The section covers the design and development of workspaces, robot operations, and lines of defense, for example, safety-rated monitored stop. It also includes speed and distance essentials and preventive hazards by continually assessing and mitigating risks. Clause 6 talks about verification and validation requirements for the design and applications. The technical report makes a normative reference to ISO 10218-2, 2011, Clause 6 on validation and verification requirements. However, the standard doesn't prescribe how to validate. My associate, Brian Carlisle, will be spending some time sharing his insights on a unique testing methodology a bit later in the course. Clause 7 talks about documented information required to meet safety objectives successfully. Let's look at potential contact situations between a robot and a human. However, at this time, let's pause and clarify the definition of a collaborative robot or COBOT. A COBOT refers to a robot with the capability of being used in a collaborative operation. A collaborative workspace is a particular kind of operation in which an operator and a robot share the same workspace. In this type of operation, the robot is power and force limited, making it safer for both the human and the robot. In this collaborative scenario, a potential contact can occur between an operator and a robot. These contacts can either be intended, incidental, or a failure of the COBOT. This contact can lead to two scenarios: quasi-static and transient contact. Quasi means apparent and static means at rest. A quasi-static contact is one where an operator's body part can clamp between the moving part of the robot and another fixed or moving part of the robot system. In this scenario, the operator's body part can potentially crush, and the operator is likely unable to retract the body part from the contact. Transient means momentary is a type of contact where the operator's body part does not clamp, unlike quasi-static. This momentary contact means the operator can quickly retract or recoil from the moving part of the robot system. Delving deeper into the possible contact scenarios, let's review a study performed by the University of Mainz. The university conducted a pain threshold study in Germany across approximately 100 test subjects. The research sampled pain limits of test subjects by exposing 29 human body parts to robot impact concerning force and speed. This research yielded the biomechanical limits of the human body in reaction to robots' force and pressure. Besides, the ISO 10218-1 and 2 talk about calculations for robot speed to adhere to within the biomechanical limits. Although this technical report includes the body model descriptions and biomechanical limits, it's continually evolving with the ultimate goal of being incorporated into its own standard. If you recall, we spent some time learning about quasi-static and transient contacts. The biomechanical limits for the applicable quasi-static and transient contacts for the 29 body parts were determined. As you can see, in the table extracted from the ISO TS 15066-2016, which appears as Annex A in the technical report, the maximum permissible pressure and force to specific body areas are calculated for quasi-static and transient contacts. The top two rows in the table are in italics, indicating the skull, forehead, and face body regions were considered critical zones. We spent some time talking about collaborative robots, system design, and applications safety. Do you recall the safety pyramid consisting of the 3 E's: elimination, engineering, and enterprise controls? Although the technical report is at a premature stage, it touches upon the two most useful components: elimination of a hazard and putting engineering controls in place to prevent a hazard. The third level, enterprise control, reviews how we can proactively enhance the safety of personnel by changing the way people work. This brings us to OSHA, which stands for Occupational Safety and Health Administration. OSHA's mission is to improve workers' safety by generating new safety knowledge and transferring existing safety knowledge into new domains such as collaborative robots. Although not as prescriptive as ISO standards, there are numerous safety lessons worth leveraging from OSHA, such as walking and working surfaces, firefighting, personal protective equipment, PPE, hazard communications, and ergonomics. In this lesson, we reviewed the essentials and structure of the RIA technical report to stimulate your thought processes and approaches regarding safety measures.